Alright. Been a minute. By a minute, it's been like, I don't know, 2 or 3 months or something. I'm back. Kinda today's goal is just to finish the Hogwarts CAD model. Then once I have this solid CAD model complete, I'll be able to throw it into my other CAD of the game and start really trying to figure out the upper playfield, the Hogwarts upper playfield. Yeah, this is what I've got so far with the CAD for Hogwarts. It's taken a lot of time. Obviously there's lots of STL files out there. You can see some on the left, different versions of Hogwarts. But I can never get them to cleanly convert to a solid file from an STL. It's kind of hard to take a mesh and make a solid out of it. So it's been a very manual process to take one of those meshes, do a bunch of cross sections, and then trace some of those cross sections to do all the geometry for this. So like this kind of center portion here where the staircases are, the moving staircases and all that stuff in this building with a larger tower. That took me about 8 hours to do that. I don't know how long it took me to do all the rest of this portion because that was just piecemeal. But yeah, where we're at, that's what we're doing. So, get back to it. I'm gonna hide my mesh here. That's eventually what it should look like, or close to it, minus the greenhouses and stuff out here. But generally, that should be the shape of it. So, what do I want to do here? All that's left is the dining hall, great hall, all that area here. So I think what I'll do is start out with the profile of the building, so the roof line and the height. And we'll extrude that. And then I'll work on getting like these front fascia portions on here. And then get this tower figured out. And then we can start getting into the details of all the windows and the little miniature towers and everything here. So if let me turn off my body. As far as the general detail here, it looks like I should be able to extrude the base of this up to the roof line. Looks like there's little kind of detail scallop portions here. But I think this same size here can extrude all the way to the roof line. I'm pretty sure I have the overall shape kind of there. Yeah, so I should be able to kind of extrude this whole thing up to the roof line. exception of maybe what's the front of that supposed to look like? So actually, I think I can take that up as well. Right on the same line here. Okay. I'll extrude that up to height. So, here's the process of how this works. I have to hide my overall body here. We go up to mesh. We go up to create mesh section sketch. Click my mesh. And then we're gonna rotate it 90 degrees. Okay. Then I don't know what exact angle that building is here. Gonna have to figure that out though. That's about 20 degrees. Seems, let's see here how much is sticking out. I think 20 degrees is about right. So then I can take this cross section and kind of slide it back and forth. I think what I'll do, try to place it right on one of those little miniature towers so I can get the cross section of that miniature tower. Kind of hone that in. What up, pancake flipper? Ugh, still working. I have vacation today, so I'm chilling. Tomorrow my brother's gonna come over to watch some Star Wars Rebels, if you're interested. He's gonna probably come over around noon, and then we're gonna hit up some Mongolian barbecue for lunch. And then watch some Rebels. More than welcome to join. Okay, I think I got that cross section right about where I want it. You see all these little miniature kind of profiles I have to extrude across the surface here. You can see like the roof line's kind of jacked up on the one side, like bumps out. I don't know if that's intentional or if that's the mesh conversion. Willing to bet it's my mesh conversion. Make it a 1.48. Let's remember that number. Yeah, jacked out the whole way across, isn't it? Maybe that is intentional? Find out. How can Mongolian barbecue not fit in your lifestyle? It's all stir-fried meats and veggies. You pick your sauce and your seasoning, so you can make it as healthy as you wish. You can have a stir-fried bowl of veggies. I plan to do something along those lines. I've been eating keto since Monday. Okay, so there is the cross section we just created. So now I'm going to go into that sketch and click Edit Sketch. Now, since that doesn't automatically create lines for me, I have to fit curves to mesh section. Select the line type, and first thing I'll do is get my overall base width. You can see it kind of knows where the corners are and things like that. It looks like this line goes all the way up there. Comes back down. All the way back down. So that's one of our mini towers. Then, since it changed your selection, you have to click OK and start this again. Dots. Oh, where that just put that. Either way. So now we're going to come back up to the roof line. That. We're going to go all the way across the roof line. There. Need to figure out. Pretty sure this roof line is intentionally different angles. Sounds cool. Thanks for joining in. If you're still there, audio and video good, just give me a thumbs up or sounds good. Did a little bit of like testing beforehand, but I think it should be alright. I'm going to continue sketching profile of the building here. Likes to be really finicky when it's trying to figure out where these lines are. Okay. So sometimes it doesn't like catch your command. Need to figure out, because this line crosses over here. I think. Or it didn't draw it. There it is. Okay. It's interesting. The angles of this roof are skewed. I don't know if it's supposed to be like that, but the entire model is that way. Let's see. Yeah, I mean, it's straight up. So this model right here is the model that they used for doing some filming. So they built a very detailed, scaled model. And they do some of like the panning and fly-through shots in the movies in this. so it looks pretty steep. So what I'll do, I think, since I got pretty good clean lines for the width of my building, I'll just do a center line. So it kind of looks like this one here might be correct. I mean, obviously it doesn't bump out like that. I'm just trying to figure out what's the angle of the roof here. Got two different angles. And let me also make sure that center of my bottom lines up. They're not exactly the same. It's also not seeing that is a complete area. I'm pretty sure that a line connected there, and that line. Same there. There we go. Wasn't detecting that as a completed region. Alright. So we will continue. Fitting the curves to the mesh. See how it wants to stretch it at an angle there? Like, even though I have the top dot, but I find if I go back the other direction, then it fixes itself. I have to go in and delete the one that did it at an angle. Okay. I don't know what this little section is here on the tower. It just escaped out of it. These lines are never like perfectly straight. So once I finish tracing my cross section, then I go in, oh my gosh, and set constraints on the lines to make them horizontal and perpendicular, or horizontal and vertical, all that stuff. And let's get the tower. These don't have to be perfect. But the way I like to work, I'll probably like try to get it as perfect as I can. Okay. One tower cap. The other one too. What I need to do. Bump outs here too. I like to try to get these all kind of sketched out because it gives me like a distance for when I set extrusions. It gives me like a mark to extrude to. And the top. Not entirely sure what these little areas are down below the cap here. It's probably like, if I were to guess, it's probably like a scalloped area. And like a little inset archway. This tower. Oh, I just escaped out of it. Ah, it's the worst. I like to pull the trigger on the escape button a little too quickly. Bad habits. Okay, so there's kind of the rough profile. I'm not going to worry about these little scalloped areas right now. Then we hide the mesh, and then we go in and start setting constraints and everything. So I set everything as horizontal and vertical. Those lines. And I thought I had two lines here. And then catch these little details here. Okay. Then when you zoom in this close on little tiny details like this, your cursor doesn't always hover over what you think you're hovering over. And yeah. Okay. Now I want to get this roof peak line all figured out. Let's set the center of this. Pull this. Just gonna center it from the base. Oh, cool. First time chat. Thank you for following. Alright. Spam bots. Cool. Probably gotta be an easy way to ban people. On the Twitch activity feed. Oh. Okay. I think you can do it there. Anywho. Back to work. Got to trace that little portion there. Let's do that real quick. Okay, make sure we set them all as horizontal and vertical. Then I'm going to use that as my kind of my point of connection for the roof line there, because I don't want that sticking up above that little detail. And can I do this maybe? Nope, that's not what I wanted. Yo, what's up, Borg Dog? Right now I am doing a very long and tedious manual process of creating mesh cross sections of a mesh file of Hogwarts, and I am tracing and extruding to recreate it as a solid, because no matter which Hogwarts file I found out there, converting that mesh to a solid just was awful. It would either crash Fusion or it would turn out nasty and webbed and all kinds of stuff. And so what I'm working on right now is like the last little bit of that I gotta do. So it is the main dining hall is what I'm doing right now. And I center that on a point. Select the point. There we go. That's what I wanted. It is the biggest pain. Okay, so that dotted line is my center line. I know that left roof line was jacked up. So now I should be able to grab this line here, Pop it there. So now we have a nice symmetric roof line. That should roughly right. There was a line missing somewhere on one of these detailed parts that I had to do. Here. Of course, that's a construction line. Nice. And then I want to do the same thing to make sure my little points here are symmetric. Those actually look pretty darn close. And I can't remember if those are square or just a revolve. They are square. So those I'll end up having to do like just a square and then extrude that up to the top point. Loft it to the top point. Well, that's the mesh, and this is how far I've gotten with converting it all. So looks great. All I've got left is just that little main dining room area, or main dining hall, great hall. Yeah. So it's gonna be printed out. It's most definitely gonna be printed in pieces. I have a resin printer that can do just about 1 cubic foot. So it'll probably be like a little building at a time, and then I'll like strategically slice it so you can't really see the seams. But the whole reason why I'm drawing this or translating this from a mesh to a solid is so that I can do some manipulation. Like, I want to see if there's a way I can build in some physical ball locks into Hogwarts itself. Like, one of the original ideas I had, which so far hasn't fleshed out, but this main tower here, I wanted to call it the Phoenix lock. I have like a 2-ball multi-ball. So you would, on the upper playfield, shoot into like a little miniature turnaround here that would load it into this tower, and then the tower would have a lift in it, and then there was going to be a window in the tower where the ball kind of like sits there and you can see it in that window, and then when that multi-ball is ready, it would kind of spit it out the window and maybe down some wire form, or I don't know. That was the original thought process. The diameter of this right now is less than 1 inch, so that's not really possible with the scale that I have right now. But I've considered scaling it up as well. It just all depends on what I end up wanting to do. So moving staircases it's been brought up by quite a few people. I don't necessarily have that, just because the scope of my game is going to be the Harry Potter universe. So like a moving staircase would be definitely a really cool mech, especially in a game that's more focused solely around Hogwarts. But because mine encompasses the universe, Hogwarts is going to be kind of like a sculpt there, but some other sculpts in the world are going to be the Quidditch playfield and Hagrid's hut and Gringotts and Ollivanders, and like the Prophecy Orb. So there's going to be like kind of a London area, there's going to be the Quidditch area, there's going to be the Dark Forest, or Forbidden Forest, and then there's going to be Hogwarts. So I didn't want to have moving staircases just because I feel like that would detract from what I'm trying to do as far as making it all-encompassing of the world. It is definitely a wide body. Here, let me finish this sketch, and I'll open up the main file here, which takes like 2 minutes to open. It's getting massive, and this was like my first time using Fusion 360, so trying to figure out the new software and what's the right way to build things in the software that keeps it clean and small. I didn't really know any of those tricks, so my Fusion file's massive. Like I did a lot of the building of components and the designing of different things within the same exact file instead of like creating separate files for each mech and then linking those, which is what made it so big. And then I did a whole lot of the, which apparently is not good practice, when you position a component or a mech or a target where you want it, you can click a thing that records the position in the relative space, which then adds an event to your timeline for every single one of those. The smarter way to do it is by using joints. It's a lot cleaner, and it uses a lot less memory trying to load the positions of all those components in a timeline fashion. Alright, it's halfway open. Doug, have you done homebrews? If so, which homebrews have you done, or are you thinking about doing one? Alright, now it's opening. There we go. My Hogwarts is out of date. So it's a wide body. And I tried to make it in a way where it plays fast for a wide body. So like my outer orbit shot, which there's a couple different ways it can go here, but the outer orbit shot, I'm gonna have a magnet to try to help accelerate the ball around that. Then like my inner orbit through the spinner here is probably about standard body orbit size. So, but like for those wider shots, I'm gonna try to use a magnet and some optos to help accelerate the ball, so those shots feel quicker. We'll see how that goes. And then I have 7 in lanes / out lanes. J.K. Rowling uses 7s a lot in kind of the way that she went about Harry Potter, like the Horcruxes and things like that. I kind of did that. Both of like the widest out lanes to help keep speed for those are actually going to feed back to your flipper. they'll kind of like jump down through a one-way gate, and then you'll have these kind of centered out lanes that are inset one lane width. I also wanted to give the ability for the player to try to get physical with the machine on the out lanes. So similar to what GGP Pirates did down here, you're gonna have the ability to nudge it back into the shooter lane. I haven't 100% decided if I want that in the game or not for right here, because there's another feature in the out lane, this area. We'll call it the Dobie ball save. So there's a magnet right here. There's a magnet right here. And the shape of this metal is such that when a ball comes down here, and if your Dobie save is lit, or whatever it's going to be, this magnet should, in theory, be able to sense when the ball is coming, pulse it real quick to fling it. It'll ride the rail here and across, and then this other magnet will then fling it up and out your out lane back into the game. Spent a lot of time on the geometry of that within CAD to make sure that like there's some good kind of wiggle room, so that as it comes off that rail and it's got that sideways momentum, that it doesn't like catch. It's gonna take some adjustment in person once I build it physically, but I think that'll be a really cool feature. So anyways, I'm not sure if I want this right save thing over here, just because I want a smooth feed to that magnet, but we'll see. And then over here on the left side, you can see my mess of gates here. That'll be a lot cleaner when I actually build it. I'll do like a sheet metal bracket to tie this all together. But so when you drain here, there's a post, and you'll have the ability to nudge it, and if you do it right, you can deflect it and nudge it up through this one-way gate here and back to your flipper. It's kind of like a different way of little physical ball save. Yeah, so there's those are kind of like my physical player interactive nudging ball save type of things. And then I have the Dobie ball save. If I can get that to work, I think that'll be really cool. I don't think anybody's tried doing something like that before. Maybe they have, I don't know. But still, I think that'll be really neat. Because I can do like some sort of coordination with light show and video and all that, so that it creates a moment. That's another big part of my design philosophy, is I want to create moments in the game. So like this whole mag rail system through the center here, I'm going to be able to, similar to Dracula, the Mist, it's going to be able to grab your ball in different positions, or fling your ball in different spots. So I have, we'll flip it over real quick. So I have a magnet mounted to this linear rail system that's stepper driven. Might be noisy, I don't really care. It's the only way I could think to get it to work the way I want it to, because I need that exact positioning. And then, so how that, a couple ideas how I think that'll play into the game. You see on like the left side here, there's a diverter. So this diverter lets a ball come out of this buck here and feed straight down to your left flipper. And when it's in the other state, would be when a ball is going to be shooting out of this left shooter lane. And that diverter will guide the ball, and I'll have the magnet kind of staged right here to grab it. So like, I'm thinking like you'd be casting a spell, and then think like in Goblet of Fire when Voldemort and Harry have their duel in the graveyard, and their wands or their spells meet, and they kind of are like pushing back and forth and fighting each other. I'll probably try to do something similar with the magnet grabbing your ball and then kind of moving back and forth, and then I'll have the light shows underneath to kind of resemble the spell coming out of the wands. So you'll have like the green and the red meeting in the middle, and they'll kind of like push back and forth with the magnet. I'm also thinking in terms of what else I can do with this magnet. So I'll know when the magnet has a ball because I have these long-range optos that are lined up right on that path. So that's how I'll be able to confirm that something is grabbed there. And then I should be able to, one thing is fling it up into this captive ball lock. So this isn't just a normal captive ball, it's actually a lock with a kind of a holder post that'll suck down and then hold. So you can, this is what I call the Horcrux area. So you'll, when you capture or collect a Horcrux, it gets trapped in there. And then, I haven't figured out any of the rules yet, but then theoretically you'll be trying to destroy the Horcrux. And whether that's a certain number of hits on that captive ball or certain shots, I don't know. But then there's a magnet in there as well so that it can fling it around, because you know in the movies when the Horcruxes are destroyed, something kind of nasty comes out and attacks and all that stuff. And it's also kind of a more dangerous shot. So if you're hitting that captive ball, it's a riskier shot because there's a chance it could kind of pause in its tracks and head towards your center. But I want it to be that way because you're going to be trying to destroy something very significant in the Harry Potter series. I forget what got us here. He asked if it was a wide body. Oh, also regarding the changing or the moving staircases, I have something similar in function, and that's this diverter mech back here. So it's kind of based off of like an old railroad turntable. So there are 1, 2, 3 ways, 4 ways into that diverter, and 1, 2, 3, 5 ways out. So there's tons and tons of combinations. So that's like what I call the sorting hat diverter. So it's like sorting where your ball goes, but that took some thinking how I was going to make that work. Because I had to, like, for each of these, I had to make sure that these items physically exist. So like this giant gear here is actually something I found that I recreated the CAD file for. It's also driven by a stepper motor, so I can control the position, and there's a homing switch on here somewhere. There's a homing opto. So that'll control the position of that, and I said there's 5 ways in. You can see kind of the flat areas here, so this is left orbit to ramp. So the left outer orbit can every shot on this game has multiple possible outcomes. So one of the outcomes for the outer left orbit is a ramp that feeds up here. And then this one right here is a center ramp that is left of the pop bumpers here. So it's a center ramp shot right here. It might end up being a little tight. I don't know exactly. I think I got like 1 1/4 inches. Oh, I got like 2 inches there. So it's actually a pretty decent shot. I'll chop off the back half of the pop bumper here, just to give it more room to curl and work its way up there. That's the center ramp. And then this other flat entrance right here is a ramp right here. So it'll kind of like snake its way up there a little bit. And then this whole diverter assembly can also be fed from the subway back here, so that I can use this diverter to feed the Hogwarts playfield. So this little wireform area, attachment area here, will likely, or the idea is that will feed the Hogwarts upper playfield, of which the flipper is right here. And that's where this Hogwarts comes into play that I've been kind of working on. And how that's all going to fit in there is kind of yet to be determined, but yeah, that's where I'm at. It's been a lot of work to get to this point. A lot of sheet metal in this game. Custom mechs and stuff. Custom mechs that I don't even know if they're going to work. But I'm gonna try my damnedest. This mech right here is Gringotts lock. So you can see the fork that comes up out of the playfield, similar to what they did for the chest in Pirates. So that mech is underneath the playfield and throws those rails up there, and then that, in theory, if it has enough velocity, which I think it should because it's like only halfway up the playfield and it's a pretty sweet spot on the flipper, it should, in theory, come up here and then feed into this 3-ball lock. Those holes are for opto sensors. I'm thinking I'm only going to put 1 opto sensor on here, just to know when a ball goes into that lock. And then I've got trying to remember. Oh, so these 2 coils are for releasing and resetting that lock. So this one right here, there's like a kind of a swing gate inside of here that holds the balls up above the wireform. So when this coil triggers, it allows that to swing back and the balls to fall out. And then this one here is a reset arm that swings it back in. That one took a lot of engineering. It was something that I wanted in the game for sure, like some sort of a Gringotts or a Weasley, like a Weasley's Wonderful Wheezes or whatever. Some sort of a multi-ball associated with that. And this shot right here, this sits underneath a sculpt of Gringotts. Then I had to make sure there was room for the wireform around that as well. So that little middle shot where that feeds from. So earlier I said every shot has multiple possible outcomes. So this inner orbit shot right here in front of the right flipper, actually has a drop ramp. Right there, you can kind of see it right there. So that's a drop ramp, so that I can take a ball out of that inner orbit as well as out of the outer orbit there, depending on what I want to do. And that feeds underneath the Quidditch playfield all the way out to that little exit that I just showed right here. So this can feed your left Master of the Drain, thanks, appreciate it. This can feed your left flipper, or if I take a ball out of that orbit using that same drop ramp, I have a designed diverter, which I'll have to 3D print this link arm here. Let me hide the Quidditch playfield. This will make it easier to visualize. Playfield and the Quidditch bracket. And this thing's probably all the way at the bottom. Finished. There, now you can see that drop ramp. And then normally the trying to remember which way the diverter works. So in the engaged state, the diverter's currently modeled here. So this little guide rail here will take balls out of that path and send them down the wire form. Or if the diverter's off, the ball should ride the outside of this rail. And then this fork here is engineered so that it kind of slowly drops that ball down to the playfield level. So it's not like an abrupt drop off of there, so it doesn't like bounce and lose momentum, because I want it to feed into that left orbit with some speed. So that right inner orbit can feed either this wire form to your left flipper, or it can feed this left outer orbit. Or, if I'm not using the drop ramp, that left or that right inner orbit comes all the way around and then back down here. And this is like the coolest shot. And then it feeds right into this outlane and Speedy Gonzalez all the way down to your right flipper. That's a really satisfying shot to hit, at least in visual pinball. I'm told that it translates fairly well to physical. But either way, I'm going to try my hardest to get that shot dialed in so that when you rip this orbit, it should shoot straight down to your outlane over here, intentionally. But if you don't get a clean enough shot on it, then it will fall down into the Whomping Willow. And the Whomping Willow is another multi-function mech. So the Willow itself will be, so kind of what you see here is the main trunk branches of the Willow. That'll be cast silicone over top of my actual mech, and then I'll kind of stitch in little branches here and there to make it more like what it looks like in the movie. But it's going to be made of silicone because inside of this mech is an actuator that's going to allow me to have two of those branches drop down and mess with the ball. And all of this sits on top of a powered spinning disc that is also multifunction, so it can engage the drive wheel to spin the disc, or it can disengage the drive wheel and be free spinning. That mech took some thought as well. But it should work. It's all engineered to work with existing components and bearings and all that stuff. Oh, and I completely forgot, the other function of this is subway entrance, because why not? Because in the movie and in the books, they have the tunnel underneath the roots of the Whomping Willow, where there was like a knot on the tree they could tickle to calm the willow. So, this is designed so that, see the dual opposing coils here, one will actuate those branches by pulling down on the inner rod, and then the other coil will push up against, so like you see my inner rod has an E-ring on it and a washer, and then there's a stainless steel tube that sits as a sleeve over top of the inner rod, and that lifts up the entire Whomping Willow disc assembly so the ball can go underneath it and enter the subway. And then I said that it's both free spinning and powered, so you can kind of see right here is my drive wheel that attaches to a DC motor, and that will be held with pressure against the inside of the disc by a spring, so that'll always keep constant pressure with that drive wheel to keep it engaged with the disc. And then I use a servo here, so when I want to make it free spinning, I use a servo here to pivot that DC motor and that drive wheel, to pivot it just like probably 1/8 of an inch so that it disengages from the spinning disc and allows it to free spin. Yeah. Oof. It's overwhelming. Like, I've spent most of this year designing all these mechs and stuff in CAD in ways that should physically work. But then the hard part is going to be actually physically making them. Like, I can send all of the cut files for the sheet metal to Send Cut Send. Kiwi Frenzy, thank you for following, appreciate it. Thank you. Like, I can send all the sheet metal files, the cut files, to Send Cut Send and get my sheet metal cutouts, but getting the bends precisely where I need them is going to be tough. But in theory, I should be able to make everything that's not an off-the-shelf part. I think this is going to be a really cool mech. I mean, from above the playfield, it just looks like, you know, it's a disc with a tree on it. But little do you know that that tree's branches can whomp you because it's cast silicone. It can spin on its own and screw with your ball even more, or it can lift the whole assembly up and swallow your ball. Oh, the subway. Well, let me explain it from the top first. So, in Harry Potter, there's the Floo Network. There's also Apparition. There's those two, like, kind of transportation methods that are instantaneous within the Harry Potter universe. So over here on the left side is a scoop. That will be the Ministry of Magic, London, Floo, fireplace type of thing. Then there's this scoop right back here, which is kind of like your Hogwarts blue fireplace or whatever I end up making it. So I wanted to conceptually have a way where when you shoot a ball into one of those scoops, it instantly pops out the other scoop. So it's like you're using the flue network to teleport, or you're apparating the ball. In this case, it would be the flue from scoop to scoop. And I also have one more kind of tucked in the back corner here that can feed this diverter assembly. And then so those are like my 3 exit points where I can eject a ball onto the playfield into your game. 2 more of note are the ones that feed into your shooter lanes here. They're also connected to the subway. So that, and this is where apparition, whatever, comes into play. So each of these outermost outlanes has a diverter where, based on the mode state of the game, I can have that diverter open so your balls go right into that outermost shooter lane thing. And then I will sense that a ball enters that shooter lane, and then it's going to just drain to your trough. But because I sensed that it came in over here, the play that I think I'm going to do with this is apparition. So it goes in here, and then instantly one shoots out your right shooter lane, or vice versa. So this right shooter lane, this thing right here is actually attached to a flipper mech, so it's just a diverter that feeds the ball to the flipper in normal cases. But if you engage that, that shooter lane's open. So now I can take a ball that's coming in right here into this shooter lane, and then instantly shoot one out the left shooter lane. So it'll be a good way of what I'll call apparating, I think. So it comes in and boom, and comes in and boom. So, long story short, I needed a way to be able to manage the balls and stage the balls at all of those exit points on the playfield. And we counted 5. The 2 that feature shooter lanes, and then the 3 Vucks. So I had to design what I call a subway circuit. And here's that fun mess of a subway circuit. So, you have, we'll start at the bottom, you have your 2 that feed into your shooter lanes, and all of these are custom. Like, I can't just buy a normal trough and use that, because all my heights are a little bit different to get everything to fit the way I need it. So it's all going to be custom cut sheet metal and then bent and assembled, but it will work. So I have the 2 ball troughs, 1 for each of the shooter lanes. I have this, we'll call it a diverter. What it does is it'll sort the incoming balls into whichever trough needs them. I could have done it probably a few different ways, because initially it was going to be like 3 exits, but now it's just 2. So I probably could have just done a 2-way diverter or something. But, so that is just a 3D printed, see, I got teeth on the bottom here that's engaged by the motor, the DC motor, and then this is just cut out so that a ball can roll into it, and then it's got enough of an angle on the floor of it so that when a ball comes in the main subway, it can turn left or right, and the angle on the bottom of that area will roll the ball out into the trough. So that'll manage the staging of the balls for troughs. And then we'll flip this back over. So this is like kind of the main line here. And if we follow this all the way back up to here, So here's that scoop on the left side that I was talking about. So this is where I can, so there'll be a diverter here, obviously, so the ball can go one way or the other when it's coming. So the direction of flow is back down to where we started, right? So this scoop here takes an off-the-shelf scoop with an open back, and then sisters a coil to the back with this custom bracket that essentially puts forks. You can kind of see them right there. So what these forks do is when you shoot that scoop, the ball will set on top of those forks. And the reason for that is because there's always going to be a ball staged, ready to go in that vuck. So I need to, if you shoot that scoop, I need to be able to eject whatever is currently in there to be able to take in the new ball. So these forks will come into play. I'll pulse the vuck coil just enough to eject the current ball into the subway. And then the forks will retract, and the ball that you shot in there will drop down and be staged and ready to go. So that's how I kind of handle the ball management. When you shoot the scoop, it does all that trickery to stage the balls ready to go. So the one that was staged here is then ejected backwards into the subway. So let's this. So, however I designed the diverter right here, that ball is going to eject backwards and up the line just a little bit here, and then it'll roll back down main sorting trough area. Then there's this other subway entrance that is inside of my inner orbit, my upper flipper orbit. So from this upper flipper you'll be able to shoot at those targets, you'll be able to shoot this orbit that feeds back to it, and then there's a hole right here that'll get your ball into the subway. There's that one there. And let's keep following the subway back around. So here's that other flue network fireplace I talked about. Same thing. Handles the balls in the same manner. There's that scoop. And then we keep going around. So here's an entrance that you won't see, but there's a magnet above it because what it'll do is it'll pull the ball out of the orbit and drop it into the subway when I need to. And then back here, this is the vuck that feeds the diverter assembly up here. So that'll feed that diverter. And then follow the trunk line all the way back down here. Okay, so here's another entrance. This one hides behind Hagrid's hut. So Hagrid's hut will sit above this. This is a bank of 4 targets that blocks that orbit shot. And then based on the mode, it can rotate to open up that orbit shot. Or, in the way that you currently see it, you can shoot underneath this upper flipper. Or some sort of a ball lock. So you would shoot under here, and it rolls back down into this subway entrance here. And then, let's go back underneath. So then we follow this all the way back to the beginning. So let me turn this upright so we can think about it in terms of gravity. So, how does this whole subway circuit you know, maintain itself and maintain the balls staged appropriately. I don't 100% know. I haven't gotten anywhere close to the code. I hope that it's doable. I think it should be doable in some sort of a workaround way. But, so, if I need to feed balls into this subway to stage them, let's say that, you know, let's say that some of these VUCs are empty because it ejected a ball. So let's say you shot this left VUC, and that fork is holding the ball up while it disposes of the other one beneath it. At the same time, this upper scoop here is going to eject the ball that it had staged there already, and now there's no ball there. So how do I get one back in position? So I have to be able to feed a ball uphill into this subway circuit to be able to stage things. So right here is just kind of like a little kickback coil. It's like a 23800, and that will shoot a ball up this subway here, and directly off the end of it there's that one that feeds the diverter thing, or it'll curl around that direction. And that's where I can feed balls to these ones around the playfield. So we'll shoot up here, come around. It can drop it into this VUC here if it needs to. It can go into the one back here that's straight off of the chute. Or it can come all the way down here to this other VUC on the left side of the playfield. And then everything eventually makes its way all the way back down to your ball trough. So those ball troughs are also, like I said, custom, because I have to be able to stage balls underneath these VUCs. That means I need to be able to have a way to feed a ball into my subway circuit. Mr. Kennedy, thank you for the follow. Appreciate it. So that's where this second coil on the trough assembly on this side will eject it up and into this little trough that feeds my subway circuit. So that'll allow me to take a ball from this trough here. It launches up, this scoop here kind of deflects it into this little miniature subway thing here. And that'll drop it down into the guy here that feeds the rest of the subway to stage balls. So that is all those tunnels underneath. That's how they work. There's a very good chance I overcomplicated things with how I engineered it. I don't know. But it should work in theory. There's a whole lot of shoulds and in theories here. Hoping that it works. It's all mechanically, physically engineered to fit together and mesh together. The questions is going to become, will it physically work as intended? Who knows how many iterations of whatever I'm going to go through, but the reason why I've taken so long to design the CAD file of this before actually cutting out anything is because I want it to physically mesh. I don't want to have like an idea for a shot and then find out that I can't fit a mech where I wanted to. So there's been a whole lot of tangoing, dancing, whatever you want to call it, to make sure all these brackets play nicely underneath here. and making sure I can fit in the features that I want. Now, as far as where I started, this all started and came from a visual pinball design that I spent hours upon hours of playtesting, days and days and weeks of playtesting, and changing and coming up with a layout that was fun to shoot in visual pinball. And from what I understand, it translates fairly accurately to a physical game. And to try to account for like any of those little things that aren't going to translate well, I make sure that my shots are wide enough, or kind of strategically have the rail extended so that it can catch the ball a little bit earlier than where the shot entrance is. So I try to account for imperfections of translating from the visual world to a physical model by making the shots a little bit wider and things like that. So we'll see how it all works. The one area that I'm still like unsure what I'm gonna do. Well, actually, there's two areas. One is this left side here, which is the Ministry London area. It's just kind of like open, weird area here, and I wanted to have like a set of drop targets there, so that I could kind of block off that scoop shot when I wanted to, and make it something you like qualify by shooting down the drop targets. But if I flip this over, there ain't room for drop targets. There ain't no done room there for drop targets. So then I thought, well, what if, since this is going to be kind of the Diagon Alley London area, what if I try to build some sort of a brick wall that rolls up like it does in the movie? Because I'm stupid and I think I can create amazing things. So I kind of engineered something up for that, and then kind of quickly gave up. I don't think I even have the file for the wall anymore. No. So I engineered like the brick wall to make it physically scale and look right. And then I had a whole mech design, which in my pamphlet of ideas, let me find that. If I even drew it inside of this pamphlet. I don't think I did. So I like sketch out all my ideas in here, in this thingy, before I actually go about putting them in CAD. Okay, so it's not in that one. I know I sketched it somewhere. And there's papers everywhere. And who knows what it is, and I just tore something else. Well, somewhere I had drawn up this idea on how it was going to roll up the bricks in a way that's similar to when you go into Diagon Alley in the movie, and he like taps the bricks and then they start kind of like folding in and on themselves. So I had that designed somewhat, but I couldn't figure out how to make the roll-up mech fit in a small space, because it can't stick out too far. Because there's like Ollivander's, I think, kind of sits above it, or whatever's ended up going there. but I need room for that wireform return to come down there. And I can't stick out too far into this orbit shot here. So it's kind of like, it's got to fill this space. So then the other idea I had, because I was like, man, drop targets would be great there. What if I designed something different? Call it a flip-up target. And open this. So this was like my second iteration at designing some sort of a flip-up target that fits in that area. So this angle right here is kind of the rail. And these flip-up targets would use micro switches to sense when you've hit them. And then the spring would attach on these tabs back here. And then that spring would be kind of deflected around the metal here. And it's really hard to explain my thought process on this. But it's like a toggle mechanism, so that where it's at currently, yeah, I can't even remember how this was gonna work. Somehow the springs were going to suck them back. Oh, that's right. Okay, so the springs would always be on tension on this. The roller on the micro switch on the flat side of this would kind of hold it upright. And then if you hit it with a ball, it would be enough of an impact to kind of flip that lever up, at which point the spring would take over and then rotate that whole flip-up target backwards. And then a reset bracket to push them back down. And that one's meh. Like, it could work, but I don't think it's going to work. So then let's open this one. So then this was like version 3, where instead of using metal for the front of the target, I was going to 3D print a target. So it looks kind of like this. And then that would, you have the pivot point where these knobs are. And then you can see, I just do like a sideways thing here. You can see from my sketch how this would work. And this would be an actual better designed toggle mechanism. So this portion right here is just going to be a metal link arm that attaches there, goes around there. So the metal link arm would look like that. And you can see my dotted lines show the two states. So target down or target up. So then back here, this is a metal portion built into the bracket. And over that metal portion, you would put a spring on there, a compression spring. And then a washer at the very front of it. So it's always putting pressure on the back side of this linkage, always pushing it forward. And what that does is when it's in this down state and it's pushing it forward, it should maintain that angle, right? And then let's say you hit the front of the target with a ball, and that target pushes backwards on this link arm and pushes against that spring that was right here. And while it rotates, this pivot point moves up above the horizontal line from where that spring is. At which point, the spring is going to push this pivot point from here up to here. And that swings that flip up thing up, and that spring should keep that held up in place. And that one I think should physically work, but it's kind of, I mean, it looks sized fine, but like these little tabs that fold down here, they're only what, 1/8 inch? Nope, oh, those are actually 1/4 inch. Okay. So, let's see, the distance from there to there is probably close to 1/4. Yep. So, I mean, that still could work. That's as far as I got with version 3. And I think version 3 is getting closer to where it needs to be. The one thing that I didn't quite figure out was the reset portion and how I push them back down into place. And I think that's just going to be something that kind of pushes right here. So similar to the other coil up top that had those fingers that pushed it back down. So I can reset it that way. But then, how do I sense that you hit the shot? I don't know, maybe a micro switch back here towards the back side of this channel. And I don't know. I'm like, well, do I need to get that complicated with it? What if I just had a linkage rod that sticks into a hole, and then you just spring, compression spring that whole linkage rod? So, I don't know. But that's kind of what I thought might go above that area over here. And I think I have something. Well, so there's Ollivanders. I think I deleted, maybe, the flip-up mech version 1. Nope, there's version 2. So that's kind of how version 2 looks. So off that flipper, there's some flip-up targets over there. And then knock those down, and you can eventually shoot the diagonally shot. And then if I put Ollivanders over top of it, what's that look like? I think it stuck out some. Yeah, so like those switches stick out, and it kind of looks halfway funky. Not the most ideal. And I don't want to push Ollivanders in any further because I want to be able to see this outer left orbit shot. Because once I bring in Gringotts, you can kind of see that shot, and it looks a little more like diagonally type of thing. So I don't want to like impede that visual space too much, because I want you to be able to see the ball coming out of that orbit. I want you to be able to see that that shot actually exists as well. Yeah, so that's that. Anywho, I'm going to get back to the boring part of the stream, where I'm trying to finish my sculpt for Hogwarts, which is over here. So I just finished getting the cross section of the mesh from there. So there's the mesh. And I already have kind of the base of this ready to go. I'm going to extrude this up to that point there. Extrude distance to object. Okay. And I might as well take this and extrude it. How far forward does that go? I can go all the way to the front of that portion there, so we'll extrude this. There. To there. And let's make sure we get all of this. Okay. And there's my other side. Probably needs that little area add in as well. Okay. Alright, so that's... join? New? Maybe? That might not be touching. So slow. I need to close the playfield file. Yeah, that worked. Okay. Close the playfield file. It's hogging up so much of my resources. Alright. Still thinking. There it goes. This top brick portion also runs, what, the full length, more or less? Yeah. We'll start at that object and extrude it to that point there. Point it. Being so slow. No way. Okay. So there's that. It's not perfect. In fact, it's actually shifted over, oddly. You like back here, there's that. And up here, there's that. Alright, let's undo those extrudes. So I had like a 20-degree angle on that cut plane. It was off just a little bit. What's gonna make this difficult? So, what could be my solution? Here's what I'm thinking. Oh, I got missed. So I'm thinking I'm gonna do a sketch. And yeah, okay. We're gonna do a sketch on the back plane. And there, and place it there. Then come up from the center of that. Construction line. And we're gonna project top of this roof there. And over to my center point line. Then come down from there. That, and then we'll do the same thing back up. In theory, this should fix that extrusion because it's squared up to the building. Then that, put it to there. Hide that. Sketches. So that looks much better. The roof line is squared up the way it should be. Okay. Make that a join operation. I don't know why it's defaulting to new body. Unless it thinks that they're not touching each other. But they should be. In theory. Oh, it's all being so slow. My computer's probably struggling handling Twitch and recording, and it's only missed 38 frames in almost 2 hours, so that's not bad at all. CPU usage isn't that high either. Alright, so there's that roof line. Cool, I did that. Wonder, can I measure what angle this surface is at? That should give me the angle of rotation of that building. Wow, it's taken forever just to calculate an angle. Okay, 159.7. So just over 20 degrees rotation is what I should have put on it. I don't know why I calculated that out. I think I need to save this before it decides it's gonna crash on me. Get that save out of the way. Yeah. We are making progress. Now let's do another mesh cross section to figure out the peak of this front portion. At well, that doesn't match what I just saw, right? Because that is coming off of direction here. Yeah. So, take 2. That angle is 69. 667. So let's try this again. We'll do and paste in that number. Alright. That should be a fairly close angle. And I forgot to do the thingy. I will be so glad when I'm done with this. So we want to figure out the line of the front here. Okay. That. I could grab the thickness of those. Actually, I'm going to slide this back and forth just a little bit because I want to see the shape of that entrance looks like. Block. There's some little tower thingies. Doorway. Might be able to get the roof line there in the front and try to get as much of this as I can. Right there is pretty close to that peak. And those should be kind of close-ish. And I have the point of the roof there. we'll work with that. And edit sketch. Fit curves to mesh. So this roof has, it appears, 2 different roof angles. Like that. Then we'll bring this back over. Close that in. That's that roof line. Then I don't really know how this looks or should look. Like it's a big arch that sucks back in a ways. I think at the very least I can get the archway in here. Diagonal, that diagonal. Or that's that. That. Right, and now we gotta do that. This might be tough. Kind of like that. That's kind of close. That portion. Oh no, how much of this I want to do here yet? So go back here. You can see that. See that kind of roof area sticks out a little bit. Looks like it's kind of like stepped in. And same there, kind of like steps inwards. So that's going to take some work to do the front of that. Let's see. That. And instead of cut, we make it a join. See how that looks. It's also a little bit funky and offset. Oh, I think it's because my mesh model isn't lined up with this portion here. So, another sketch on surface here. And then we'll project points there. That edge and that edge. Add bodies in the basement. That. There. Offset just a little bit. And what I want to do is create a line from here to here. And I think that's horizontal. I can't do that because it's locked down. Okay. Want to center that. But did it center both of them? Want center point of this incident this way. Okay. Right. Am I thinking about this wrong? That's what I want to do. This will make sense in a second, I swear. So I want the center of this line to be on that point there. Okay. Now I can draw Oh, I was doing the wrong point. Wrong point there too. Arr. I'll change that to a construction line, whatever. Okay. So this should give me a symmetric roof line that very closely matches the mesh. Okay. Something ain't right. Because it doesn't think it's a complete area. And what did I do wrong? Those two aren't attached, apparently. Alright, we're gonna coincident that. No! Other way. That's also annoying. Can't tell it which way you want to go. There we go. So finicky. Alright. Now let's extrude this from this face to that face. And join. Oh, it's so slow. Oh. Why did that take forever? I'm thinking I'm probably gonna have to shut it down here. No point in streaming when it takes 2 minutes to run an operation. So there's that. There's that thingy there. It matches pretty well. So that's the basic shape of the Great Hall. Call it. So now I gotta add all the little frills to it. That'll be another day. Anywho, if you've been chillin', thanks for chillin'. I appreciate each and every one of you. Let me see if other people are streaming, which I'm sure there are, that we can aid. Anyone? Nobody's streaming pinball stuff. I can tell. Maybe? Not really? No? Okay. Alright, well, hey, thanks for hanging out. I appreciate it. Hopefully I answered any and all the questions. And I'll try to stream more as I keep going. And yeah, that's it. So have a good one. Have a good weekend. And if I don't see you, have a great holiday season.